My name is Ryan Vincent, and in this screencast I will discuss two different approaches in teaching algebraic thinking. More specifically, I'll describe a lesson I created in an effort to help a specific student with a math difficulty in finding the value of a variable that makes an equation true. Some background on student A. Through observation, I've noticed when she enters the classroom, she is immediately focused on my intern mentor teacher's instruction, and she maintains that focus. I've also observed student A become obviously and visibly frustrated when she doesn't understand something. Totally understandable, since she is almost always focused on the instruction, she tries really hard, and she wants to get the right answer. My intern mentor teacher confirmed that at one point during initial instruction, during the individual part of the lesson, student A completely shut down when trying to find the value of a variable that makes an equation true. The initial instruction was straight out of the text and followed an I do, we do, you do format, with the teacher instructing students to solve for the variable by isolating it. She instructed the students to use inverse operations to do so. She defined what inverse operations were, and she modeled how to use them to solve problems. Using the text, she also described the addition property of equality, which states that when you add the same number to both sides of an equation, the two sides remain equal. And she also did the same for the subtraction property of equality. Then, using a projector, she proceeded to model solving problems by isolating the variable by using inverse operations. During the we do part of the lesson, students wrote down in their math notebooks exactly what the teacher wrote down. It was now time for individual work. And shortly after, this is what student A looked like. A couple of weeks later, I had the opportunity to revisit this lesson with student A during a 30-minute tutoring session. The class had moved on to other math concepts, and for the most part, student A seemed more comfortable with finding the values of variables in equations, and she was able to solve many of the more basic problems in her head. So we considered this to be more of a review. I started my lesson by having student A access prior knowledge by substituting values for A and B and X and Y. As you can see here, near the top of the page, problem number 2, she was substituting values for Y and X and then solving. I then went to the textbook all the way to the beginning of the chapter, where it compares two sides of an equation to two sides of a scale. Here on the right, we can see that if we take one block away from the left side of the scale, we also need to take one block away from the right side of the scale to keep it balanced, to keep it equal. Here we want to find the value of the red ball N. The scale is in balance. The two sides of the scale are equal. The two sides of the equation are equal. The left side of the scale has the ball N plus 3 blocks. The right side of the scale has 7 blocks. So, N plus 3 equals 7. I then placed 2 paper plates with a ping pong ball and Legos on the table. The 2 paper plates represented the two sides of a scale, the two sides of an equation. I asked student A to model what she saw in the text with N plus 3 equals 7. She placed the ping pong ball and 3 Legos on the left plate and 7 Legos on the right plate, and I asked her to find the value of the ping pong ball. She immediately took 3 Legos off the left plate, and she took 3 Legos off the right plate. The 2 plates were in balance, with the ping pong ball equaling 4 Legos. I asked student A to solve 4 more problems on the worksheet using the manipulatives, putting the ping pong ball in place of the variable in each equation. Here we see she was able to solve the problems correctly, the problems being number 2, A, B, C, and D. She was able to do these very quickly, and it seemed to be very intuitive using the manipulatives. I then reintroduced the idea of the addition property of equality and the subtraction property of equality, and asked her to solve a few more problems without using the manipulatives by keeping both sides of the equation in balance, and she was able to do so, as you can see here. I did not bring up the idea of inverse operations. Instead, what happened was student A was able to see a pattern after solving several examples of equations and develop rules for solving them. As our Van de Waal text states, algebra is generalized arithmetic, and for students to generalize an operation or pattern, they must look at several examples and notice what is happening in the problem. Student A was beginning to touch on forming generalizations through her own experience with the manipulatives and through multiple experiences with multiple problems. She was using inverse operations to solve problems without thinking of the term inverse operations. The last thing I chose to do was leave student A with a word problem. You eat 8 blueberries and your friend eats 11 blueberries from a package. There are 23 blueberries left. How many blueberries are in a full package? Student A immediately grabbed 8 Legos, then 11 Legos, then 23 Legos for a total of 42 Legos. She hesitated and seemed to be thinking about how to write the equation on the worksheet. After a total of about 5 minutes, you can see here how she solved the problem. As her variable, she wrote out the word full package and subtracted 8 and 11 from it on one side of the equation. On the other side of the equation, she correctly put 23. She still seemed a little uncomfortable with using any variable to represent the full package of blueberries. However, I was pleased to see that we had reinforced the importance of keeping both sides of an equation in balance. In the end, I'm not 100% sure I added to student A's understanding, as she was very quick to solve the problems on the worksheet. However, in tutoring student A, I was able to see the value of having students use manipulatives and begin to discover patterns on their own, as opposed to simply telling them what steps to memorize in solving a problem.